Okay, this is number 8 on the test review for 1.3 to 1.5. We have a fish population where in a certain lake it rises and falls according to the formula F is equal to 1,000 times 30 plus 17t minus t squared, where F is the number of fish at time t, where t is measured in years since January 1st of 2002 when the fish population was first estimated. So when they ask us on what date will the fish population again be the same as on January 1st of 2002, they're telling us that we want to know what did we start with in our fish population at time equals 0. So when we first started estimating the fish population, time is equal to 0. So we have to figure out how many fish we started with by plugging in 0. And once we find out the fish population, we can plug that in to find out the time for that. So first, we're going to take F equals 1,000 times 30 plus 17 times 0 minus 0 squared. So these, when you're multiplying times 0 and 0 squared, those are both 0. So you end up with 1,000 times 30, which is 30,000. All right. So when you know the fish population, now we can plug that in for F and calculate T. So we're going to take 30,000 and set that equal to the 1,000 times 30 minus plus 17t minus t squared and solve for t. So we're going to divide out the 1,000 from both sides. We get 30 equals 30 plus 17t minus t squared. So we've got a quadratic forming here. So we're going to set this equal to 0. So we got to get rid of the 30 here. So we're going to subtract 30 from both sides. That happens to give us 0 equals 17t minus t squared, because that 30 also cancels out. At this point, you need to realize we only have two terms with a quadratic. So both terms have a t. So we're going to factor out t. And we get 17, t times 17 minus t is equal to 0. Now that we have the two factors here, we're going to set them both equal to 0. So t equals 0, which actually we knew from up above, and 17 minus t equals 0. We're going to add t to both sides and find that 17 is equal to t. So the other time frame is 17 years later for that fish population to be the same. So 17 years later from 2002 is 2019. So our answer to this is January 1st of 2019 is when the fish population will be the same. Part B, it says by what date will the fish in the lake have all died? And what they're telling us there is that the fish population will be 0 because they will all be dead. So we're going to plug in 0 for F and then work through this problem again, just like we did above, to calculate out T. So instead of 30,000, we're working with 0. So we're going to divide by 1,000 on both sides. That gives us 0 equals 30 plus 17t minus t squared. We are already set equal to 0, so now we just need to solve this quadratic. Factors of 30 are not going to add up to 17. I have a equals negative 1, b equals 17, and c equals 30. Since this quadratic is written backwards, I have to pay attention to my a, b, and c. And I'm going to use quadratic formula. So x equals negative 17 plus or minus the square root of 17 squared minus 4 times negative 1 times 30 all over 2 times negative 1. And when I go to simplify the underneath part here of the radical, I'm going to get 289 plus 120, which is 409. And so that gives me negative 17 plus or minus the square root of 409 over negative 2. The square root of 409 is 20.2237. And that's over negative 2. Now, the reason I'm converting that to a decimal is because I need to figure out what date, I need how many years, whatever, um, passed. So having a simplified radical is not going to help me understand that information. So now I have negative 17 plus the 20.2237 over negative 2, and I have negative 17 minus the 20.2237 over negative 2. If I add negative 17 to 20.2237, I get 3.2237 divided by negative 2, which is a negative 1.6. I cannot have negative time value, so that's not going to work. So I go over to my other problem here, and when I take negative 17 minus 20.2237, I'm going to get negative 37.2237. When I divide that by negative 2, I will get 18.61185. And at this point, I can take 18.6 and calculate that for a number of years. So 18 years plus zero point 0.6 of a year. So remember, my starting date was January 1st of 2002. So 18 years later, if I take away the 18, that's going to be 2020. And then 0.6. So since there's 12 months in a year, I'm going to multiply that by 0.6. That gives me 7.2. So 7 months from January 1st, that goes from January to February to March to April to May to June, July to August. So 7 months later would be August. So August, that's the 7 months. Now, point 2 is talking about the number of days. So point 2, since we're talking about August, we're going to multiply by 31 days, and that is going to give me 6.2. So August, and then from the 1st, 6 days later is the 7th. So August 7th of 2020 is the date that these fish will all be dead. All right. Number 9 talks about a farmer with a rectangular garden plot. So we've got this rectangular garden plot. The it's got 202 feet of fence. That's the perimeter. So the perimeter is 202. Find the length and width of the garden if the area equals 2,368. So we have to think about how do you find area and perimeter. Well, if we've got length times width for area, the perimeter is going to add all of these together. So you got 2L plus 2W. And we are going to set these each equal to their values. So L times W is going to be equal to the 2,368. The 2L plus 2W is going to equal 202. So now what we're going to do is we're going to solve for either L or W so that we can come up with a substitution value to plug into the other equation. I'm going to solve the perimeter formula for L. So I'm going to first to factor out the 2. So I get 2 times L plus W equals 202. I'm going to divide out the 2. That gives me L plus W equals 101. And then I'm going to subtract the W, and I get L is equal to 101 minus W. So that is my substitution value for L in my area equation. So I'm going to get, in place of L, 101 minus W, and then that's times the W, equals 2,368. Okay, I'm going to move all this over, give myself some room to work. I'm going to distribute the W. I will get 101W minus W squared equals 2368. You can see a quadratic forming here, so I'm going to move everything over. I'm going to add the W squared to get a positive W squared, and then I'll subtract the 101W. So I'm going to subtract the 101W and add the W squared. And that gives me W squared minus 101W plus 2368 equals 0. Okay? Giving myself some room to work here. I'm going to erase some of this, and I'm going to move this stuff over. Okay. Now I'm going to use the quadratic formula for this. So A equals 1, B equals negative 101, and C equals 2,368. So I'm going to have the opposite of negative 101 plus or minus the square root of negative 101 squared minus 4 times 1 times 2368 all over 2 times 1, so 2. When I simplify the inside here, I will get 729. So this inside here is 729. And if I take the square root of 729, that gives me 27. So I'm going to have, again, I got to create room. So I'm going to have 101 plus or minus 27, because the square root of 729 is 27, over 2. And I will get 101 plus 27 over 2, which is 64. And then I'm going to have 101 minus 27 over 2, which is 74. Okay? No, divided by 2, which is going to be 37. So 64 and 37 are my two values here, because basically if I take 64, it's going to be multiplied by 37 to get my 2,368. So essentially, if my length is 64, my width would be 37. If my length was 37, my width would be 64. But all they ask for is what were the length and the width. So my dimensions are 64 feet by 37 feet. I will do number 10 in a different video.